is moving so incredibly fast that the very rules we use to measure it and even to govern it are starting to break. Today, we're going to dive into this brand new landscape, a world where genius is actually getting smaller, and our ability to figure out what's really going on is facing its biggest test yet. So let's kick things off with a number that should really make you pause: 142. That is how much smaller AI models have gotten to achieve the exact same high-level performance in just 2 years. Think about that. This isn't just a small improvement, it's a total shift in how cutting-edge AI works, who can afford it, and who can build it. And that, of course, raises two huge questions that we're going to try to unpack here. First, how is this incredible efficiency revolution even happening? And maybe more importantly, when AI is changing this fast, how can our governments and our tests, our benchmarks, even begin to keep up? Okay, so let's start with the governance piece, because right now the global AI map is being completely redrawn. The whole conversation has shifted from governments just thinking about using AI to them figuring out how to actually harness its power for all of society. This slide really shows you how much the thinking has grown up. The Government AI Readiness Index, which is a really important global report, used to just ask, can a government plug AI into its services? But look at the new question. It's so much broader, so much more strategic. It's now about whether a government can actually steer this technology with policy, with infrastructure, with talent to create real public good and drive innovation. It's a completely different way of looking at the problem. And this new strategic focus is creating a new kind of global reality. We're seeing this split emerge between what you could call model makers and model takers. The makers are basically the US and China, the places with the massive compute power and talent to build these giant foundational AI systems from the ground up. The takers, well, that's pretty much everyone else. Their challenge isn't building a new GPT. It's deciding which models to use, how to regulate them, and how to build a strong economy on top of tech that was invented somewhere else. So, okay, if the way we govern AI is changing, what about how we measure it? Well, here's the thing. We have a problem. Our measuring sticks are breaking. But the real question is, are they breaking because AI is just getting too smart, or is it because we're just not asking the right questions anymore? Just take a look at these names: MMLU, GSM-8K, Human Eval. For years, these were the gold standard exams for AI. I mean, they were designed to be incredibly difficult. But now, the top AI models are just acing them. They've become saturated. It's a fancy way of saying they're just not useful anymore for telling the best models apart. We've basically hit the ceiling of the test. And this is why it's such a massive deal. I mean, as this quote says, if you can't accurately measure what an AI can do, you can't possibly understand its risks, you can't write good policy, you're basically flying blind. These benchmarks are supposed to be the bedrock of safe AI development, and ours are going out of date. So what do? Well, researchers built something new, something much, much harder. They gave it a pretty dramatic name: Humanity's Last Exam. And the idea behind it was simple but kind of brutal. If any existing AI could answer a question correctly, that question got thrown out. This test is made up only of problems that stumped the very best AI systems we have. And what happened? The best performing AI in the entire world scored a measly 8.8%. Just let that sink in. This number is just staggering. It shows this massive, massive gap between how well AI does on those old tests and what true expert-level human reasoning looks like. It's a really important reality check on how we think about AI progress. Okay, so how are models making these incredible jumps on some tests while getting smaller and more efficient at the same time? Well, it all comes down to a revolution in two things: how they're built and how they think. This slide right here, this is that 142x reduction we started with, perfectly laid out. Back in 2022, you needed this absolute monster of a model, Google's Palm, with 540 billion parameters, just to clear a key benchmark.
Fast forward to 2024, and Microsoft's Phi 3 Mini can do the exact same thing with less than 4 billion parameters. It's all about smarter algorithms, better training data, and refined designs. It proves that just throwing more power at the problem isn't the only way anymore.
And one of the biggest new tricks up their sleeve is something called test time compute. Honestly, the best way to think about it is like giving the AI extra time and some scratch paper. Instead of just blurting out the first answer it comes up with, the model is encouraged to explore different ways of reasoning, to check its own work, and sort of refine its thinking before it gives you the final answer.
So, you have to ask, does it actually work? Well, the answer seems to be a huge yes. Just look at this jump. It's incredible. On a ridiculously hard math exam, the standard GPT-4o, which is brilliant, scores under 10%. But a model called O1, using this new thinking time method, scores over 74%. That's not just a little bit better, that is a totally different class of performance.
And here's kind of a simplified look at how it actually happens. The model doesn't just go straight from the question to the answer. First, it generates a few different ways it could solve the problem, kind of like a student trying out different formulas. Then, it actually evaluates those different paths, mixes and matches ideas, and only then does it pick the one that looks best to generate the final answer. It's a much more deliberate and, well, it seems like a much more intelligent process.
But you knew there had to be a catch, right? And there is. This deeper reasoning comes at a really steep price. It's almost 6 times more expensive to run, and it's a whopping 30 times slower than a standard model. So what that means is, while it's amazingly powerful for really specific, important problems, it's just not practical for the kind of real-time, snappy AI we use every day in chatbots. Not yet, anyway.
And this brings us to the really critical twist we've been building up to. We've got these incredible performance gains, these super efficient new models, but how real is all this progress? Because some researchers are now saying, hey, hold on a minute, and suggesting that what we're seeing might, at least in part, be an illusion.
This right here reveals a pretty big gap between the hype and the reality. When independent researchers try to recreate these amazing results that developers report, but they do it under really strict, standardized conditions, the scores often drop a lot, sometimes by as much as 17%. It shows that what a company claims its model can do and what can be reliably proven aren't always the same thing. And here it is, the heart of the matter, from the very authoritative State of AI report. It's basically saying that many of these celebrated jumps in reasoning might just be statistical noise. They fall within the normal margin of error you get when you run the same test over and over. So we can't be sure if the model is actually smarter or if it just got kind of lucky on that one particular test run. So why does this happen? Well, there are 3 main reasons. First, like we just said, the gains often aren't statistically significant. Second, these models are super sensitive. You change one word in the prompt, or you run the test on different hardware, and you can get a totally different result. And third, a lot of these advanced tests have so few questions that getting just one extra question right can make a model score jump by a huge misleading amount. And this slide, this just illustrates perfectly how fragile this so-called reasoning can be. It's amazing. On the left, you've got a complex math problem, and the model solves it. Great. Now, on the right, it's the exact same problem, but with one totally irrelevant sentence added about cats. The logic of the problem hasn't changed at all. And yet, boom, the model completely fails. This is a huge clue that it's not really reasoning like a human. It's doing some kind of very brittle pattern matching that's easily confused. Which leaves us with this final, really critical question. We're in this moment where AI is getting more efficient and more accessible than ever before. Governments are totally changing their strategies to deal with it. But at the exact same time, the tools we use to measure it are failing, and its most amazing tricks seem to be shockingly fragile. So, how do we really know if we're moving forward? How can we be sure we aren't just getting better at building systems that are really, really good at passing tests?